I'm CK. Today we've got one that's probably going to be fun. It's a little battleship with LEDs and music and other things. So let's take a look at it, see how it works, put it together, and I hope you enjoyed the video. Let's see what's in the box. It's Banria DIY Battleship soldering practice with RGB lights, music, fun STEM electronic soldering. Great, made in China. Let's open the box up. Got a bag, and the instructions are in the bag. We'll get the box ready for recycling. Now we'll try and open this without using scissors. Yay, I did it! Oh, and I also tore it apart. Look at that. Looks like, well, looky here, it looks like we've got a whole bunch of surface mount LEDs. That'll be fun. A USB-C, USB-A to USB-C power connector. Let's take a look at the instructions. Actually, let's take a look at the circuit board. So here's the deck of the battleship. Whole bunch of LEDs, surface mount LEDs. Then we've got one chip, looks like a couple of transistors here, surface mount again, another chip, a joint for the superstructure, some resistors, some capacitors, some electrolytic capacitors, and a switch here, and then this looks like the USB connector positioning. And music, that's probably a switch. I'm going to bet that's a switch. So if that's a switch, then that's probably the music chip that goes along with it. And we'll look at more of the circuit board stuff after we look at the instructions. And this is my second Banria cart, but again, this is not from Banria. It looks like it's from RGB. Oh, okay. So this is all in German. And this is in English, so you can learn your German. Battleship / shift, and so on. And we've got a whole bunch of stuff. We've got the KT 14148 Alpha. I don't know what that chip is. I'll look that up. And again, the instructions are all really good, and lots of pictures, as you can see. And we've got a little conning tower that we're going to install some stuff on also. No schematic. Oh, we've got some guns, and they've got green ceramic filaments to light up for that. That'll be fun. 3D stereoscopic display effect. No schematic, but there may be one if I follow that QR code. So the component listing is all here, including the, I've got to double check this. See, they're lying to me. Golly. Because it says, note, users can complete the installation according to the PCB silkscreen and component list. Well, the silkscreen doesn't list values, and if I look at, say, the resistors, oh, there we are, metal film resistors. Okay, PCB marking is there. I was incorrect, so we don't necessarily need the build guide, but we'll follow it just for fun. So here's the resistors, just 4 of them, and they're all the same. And we've got our conning tower. There's one of our guns, cannons, whatever you want to call it. Got a little speaker to make noise. I'm going to need 2 parts trays. one for the... Where did I put all my parts trays? There we go, I found one. But again, I've got 4 of them and I could only find 2. So I'm going to put all the PCB components in a separate tray. And here we've got the walls of the ship, or hull sides, walls. What am I talking about? Walls. Another cannon, more for the conning tower socket, and here is the filament. I don't know if these are polarized or not. Let me take a quick look at that, because I have not done this before. Oh, it's got a very, very tiny marking. Yeah, it's got a mark here, and that mark indicates the positive side. It's not really a mark, it's a cutout. So let's see if this will light up with my meter in continuity mode, so we can see how this looks. Get in continuity mode. So we've got a little current going through the probes. And did I just do that backwards? Yes, I did just do that backwards. Oh no, I didn't do it backwards. I did it the correct way. Oops, and now I dropped it. Doesn't have much to grab onto. Yeah, there you go. See, it glows a little green. So I'm sure it'll glow boom, boom, boom when it fires. At least I hope so. Put that over there. And we've got 3 of those because we've got 3 cannon. And 1 electrolytic, 2.2 microfarad. Don't put it in that bin, put it in the other bin. Switch, turn it on and off. Another piece of the conning tower. In total we've got 3 fluorescing tubes for the cannon. Here is the STC, so this is the microcontroller. It doesn't show, often they will have a little dot or a highlighter stripe to indicate that it's been programmed. This does not have that, but I'm going to assume it's programmed. Here is the USB connector. Here's a little push button switch that you can set modes with, I believe. Another electrolytic, and this one is also 2.2 microfarad. A couple of more pieces of ship. 1 transistor, 2 transistor, kind of floating around loose. And here is again, I believe, the sound chip. And here we've got a number of 104s and a couple of 105s. So it looks like we've got some surface, some through-hole assembly, some surface mount assembly, and some mechanical assembly. So this will be a good variety kit and keep us busy for more than 10 minutes. So I'll get the soldering iron heated up and we'll start putting this fella together. I brought up the build guide online. It's the same as the paper, just the pictures are a little bigger, so I'll be looking at that. It does not have a schematic. It's okay. First thing we're going to do, and why I'm zoomed in so closely, is we're going to do the IC right here, the voice chip. And to do that, surface mount, of course, with close pins. So I'm going to be using my MG Chemical 0.025 diameter solder. Get that ready. Oops, I got to change my soldering tip. I was doing the guitar amp earlier today, so I gotta, and of course I turned it on, so it's all hot. Oh, the other thing I'm going to be using some Chip Quick flux to make sure the solder doesn't bleed across pins. This costs like 20 bucks. It's got 50 grams of flux in it, and it's probably going to last me the rest of my life. So how are we going to do this? First thing I'm going to do is I'm going to go manual on the focus on this so it doesn't autofocus on me, or on you rather. I'm not going to notice. So what I'm going to do is get my surface mount tweezers, some little bent tip tweezers like so. I have a video on my channel about tweezers, why they're useful, and the different types I use on my electronics workbench. So to do this, first thing I'm going to do is I'm going to put some solder on this pad, the pad where pin 1 goes. Now I'm going to actually move this around. I'm still in frame, good. And I'm going to take the chip, and you can see there's a notch on the printing on the circuit board, and on the chip itself there is, where's my pointy thing? There is a little dot right here to indicate where leg 1 or pin 1, whatever you want to call it, of the IC is. I'm going to take my tweezers and I'm going to do something else. What did I just do with that? And I flipped the chip over, of course. Come on. There we go. I'm going to get my head in the shot probably, because I'm going to line the legs of the IC up with the pads on the board. And I'm going to heat up, let me get this, there we go, I'm going to heat up that little pool of solder I put on there. And the legs settled into it. So now, as you can see, it's firmly on the board, even though I did bleed across, but we'll fix that in a minute. And actually it's not quite right, so again I'm going to seriously get my head in the shot right now. Now the pins are all aligned. So I did this pin first to lock the thing to the board, so I'm going to flip around to the other side to do the other side first, so I don't accidentally heat that leg up again and cause it to come loose. I'm going to rub some Chip Quick in here between the pins, because that helps the solder stay on the metal part and not bridge. Now I'm going to put my soldering tip between the legs, run some solder in there. That's one leg. It's 2 legs. Actually, I got enough solder on the tip of my iron that it's gonna let me pick that up and make sure they're all good. This one, the first one, needs to have a little more solder on it. And as you can see, the solder has not flowed between the pins because of the Chip Quick, so there's no bridging going on. I'm having trouble getting this one to adhere. Let me take a look. I think that's going to be good. Now we'll do the same thing on the remaining legs on this side. A little more Chip Quick. Again, there's lots of solder pastes, flux pastes out there. I just happen to use Chipquik. I'm sure there's other stuff just as good. I happen to use it. I happen to like it. It never fails me. So I have no reason to change, but I am not endorsing it. Just using it. Check those pins. They all look good and they are not bridged. Is that one down? I'm going to try a little bit, coax a little bit. I got my, one thing I didn't do right, I didn't get the tip of my iron right. Because I've used the soldering iron so much, the cord is bent in a particular way from the way I always hold it, so I have to resettle it when I change tips, and I forget sometimes. Just touching this one up a little bit. There we go. Oh, why don't we do that one over there? And I think, beautiful. Beautiful, beautiful. That's all of them. So that's really the hardest part out of the way right at the top. And then they go through the whole sequence I just went through. Adjacent pins must not be short-circuited. Yes, I believe that is correct. I believe that would be the right thing. Okay, we're going to put the two, they're not transistors, they're voltage regulators that I'm going to be putting on, and they go here and here. I'm going to handle this one slightly differently. Same basic theory, but for one thing I'm not going to use Chipquik because the pins are far enough apart that I don't need to. So I am going to put my little pool of solder here on there. Flip this around again because I'm always backwards. I think these both are the same part number. I believe they are. If they're not, this is a 51117, and this is a 117 also. Good. So same basic technique. Get my head in the shot as part of the technique. Reheat that solder pad. And that will stay in place. I'll do the other one. Now these are 3.3 volt, I think is what it says on there. So that's taking our input voltage, which is 4.5, 5 volts, whatever, USB power, depending on what you get. That's a little crooked. Doesn't matter, I could do it well. I could do it so it adhered, that's for sure. But I'll just get it more close. There we go. And as you can see, the pitch on those pins is a lot wider than on the sound IC, so I don't have to worry so much. I'm not going to use Chipquik. I'm not going to use any flux to separate it because I don't really need to. Again, put your soldering iron between the legs, feed some solder in there. Try and get solder on the component leg and not just on your soldering iron, as I keep doing. And there's those voltage regulators on board. So we've got the hardest parts out of the way. First hardest, second hardest. Now we're going to do the the LEDs. I've got a bunch of them, and I'm going to get a different parts tray. In fact, I'm going to get a parts bowl. Go to a different part of the shop. Grab that off my alternate workbench. And I'm going to take the LEDs out. And always remember, when you're working with these strips of componentry, they are a pain for you to work with because they're not designed for you. They're designed for a machine to work with. So they are not intended to be easy for human fingers to manipulate. But just lift that little piece of clear plastic. They all jump out in there. These are, I think they're multicolor. I think they're red, green, blue LEDs. So this is rather high class. These are good quality components. Normally don't get this good a quality on this level of kit. Now, the way we know where the cathode is on, set one of them here. I hope you can see this. Let me take a look. Maybe. If you look at the printing on the circuit board, one edge is kind of clipped, and on the LED packaging, there's one edge that's kind of clipped. It's hard to, I'm pretty sure it's hard to see from the view you're getting. Let me see if I can bring it up better. And focus, focus, focus. Let's see how close I can get. I know, I'm driving you crazy probably. So you may be able to see there's a little notch right there. But that tells you where it's going. Let me get back to my other focus. So I will be doing it for all these LEDs, and they go all the way around. And they also go on here, and on here, oh yeah, on there. I think that's all. So I will be doing the same thing as we did just a moment ago with the integrated circuits and the voltage regulators. I'll put a little glob of solder there. Flip the board around again like I always do, because I always do it wrong. Always. And then we'll go back over here. And the legs don't stick out on these, they're kind of underneath, but you can pretty much tell when they're soldered anyway. And there, that's in place. And same thing as before, even though we don't have to worry about heating other pins, because there's a great deal of distance. These are pretty easy to put on as such things go. So there's one cathode and 3 anodes for the different colors of red, green, and blue on the LED. So I think I can demonstrate this. Let me bring my meter in, put it on continuity mode. So it beeps, which means there's a little bit of current going through it. And I'll put the negative on that cathode pin that we noted before. And then try this one. Yep. Try this one. No, I'm not getting it. Maybe I'm not. it's not providing enough power. Let me get one out of its... See if I can do it this way. I probably can't. No, I'm not getting them to light up. Oh well. But that's the basic idea, and I've got a whole bunch more of these to do, and I will put my playback into fast motion, no commentary, and probably cut a whole bunch of this stuff out. All the multicolor LEDs are installed. I think all the leads are connected. It's kind of hard to tell with these that are really designed for solder paste and a reflow oven or a heating plate, hot plate or something like that, but we'll see when we build it up. And then they gave us 2 extras, so I will put those in my extra stuff from kits box, so I have them for when I may need them in the future or want to play with them in the future. Now where's my, there it is. Okay, and skipping through all that, and now we're going to put the USB connector on, and it goes back here, and it's got, and it's flipping around in my hands, and it's got some index pins in the back. Oops, it does not stay in place. I felt it click and I thought the legs would support it, but apparently not. Let me put these over here. Little bitty connections. Got support legs here. If I can get them soldered. In a bit of a pain. Here, that's one. It's 2, and then these pins on the back are what's actually pulling the current. I think that's good. That didn't. The solder pads on the board are pretty, darn it, pretty small. I would have liked for them to have been bigger. What I'm going to do while I'm just sitting here is I'm going to get my meter out, put it on volts DC, and plug this in and make sure I'm getting power at that solder connection. Plug this in here. Where's an extra spot? Oh, what is this one connected to? That's not connected to anything. So we'll plug this in here, and then the little probes. Oh yeah, I'm getting 5 volts. That's it's showing negative just because I have the probes backwards, but of course any modern meter will adapt to that and let you know what's really happening. I'm going to see if I'm going to make sure it's getting power to where the switch is actually going to go, and that should be here. Oops. Should be there. Yep, it's getting to the switch. So that's what's important. Pull it back out. And now we'll do the 5 resistors, or 5 resistors. They're all the same value. What are they? Let me look. They are 1K. Of course, it's always interesting. Let me get the meter out of the way. We don't need the meter now. Always the big question, how close to the body do I want to bend the leads? And in this case, we want to bend the leads very close to the body. That's the resistors. Now we're going to put the socket on for the microprocessor. And there is, and my light is wrong. Hold on a second, I'm adjusting my light a little bit. Still look good to you? Yeah, it still looks good to you. And as you can see here, it's a little notch printed on the board, and there's a notch on the socket. I'm putting the little mode switch for the lights and sound, I believe. It calls it music, but I think it also affects the light, but I could very well be wrong. We will see when we power it on up. Now we're going to do the 104 caps. Decoupling caps, and then we'll put the toggle switch on, and it doesn't matter which way it goes, it'll figure it out. Now we'll do the two electrolytics, and again they're both 2.2, and as you can note on the circuit board, there's a shaded part of the circle, and that is where the negative side goes, and also the square pin is where the long or positive lead of the capacitor goes. Now he wants us to put the chip in the socket. I guess we'll do that now. Actually, let me see how close the mask gets to that, because I think I'm going to wait until later. Now we're going to put the speaker on the back. Should be good, and it's good. Now we're going to take this little protective ring off. It's got a little adhesive. Now we're going to do our little illuminated guns. Huh. You see, I should have 4 of these, and I do not see 4 of them. Again, I do not see 4 of them, so I'm only going to do 2 of them. I mean, 3 of them. Where is the other one? Either fell, or I dropped it, or something. Huh. Oh well. It'll work just fine with 2. And let's see what we've got here. We want the longer side with the pin, with the hole in it on the O2 side. And it looks like we're going to have to bend these down a little bit. Actually, I'm going to do a similar thing to what I did for the surface mount stuff. I'm going to put a little dab of solder there, a little dab of solder here. Get the long pin there. Reverse it, of course. Heat that solder up again. Let it sink in. That's that, unless I can find out where that other thing is. And now we're going to start putting the body pieces on. And I'm going to take a little break before we do that. I still can't find that other tube. and I'm going to have to review the video and figure out if it was even in the bag and I just dropped it. So I did check this, and we've got these two. Let me get the polarity correct. These two light up just fine, and they're apparently they're not in series, because even this one with no jumper lights up, so they must be in parallel. So I'm not going to worry about it. I don't have to put a jumper in. That's what I was thinking, but we're not going to do that. So now we're going to build the actual hull pieces. So what we're going to be doing there is we're going to get two pieces, HE51B and HE51A. HE51, HE51C, those are both C's. This is a HE051B, good. And where's 51A? There's another C. Where is an A? Oh, I see. The master is the 51A, the main hull piece. So we're going to take the B's and put them on, and as you can see, they've got little solder pads on them, and these are marked as, so you can see on the inside the AB, AB, AB goes to the AB, AB, and these will fit on like this, like so. Hopefully they friction fit pretty tightly. Of course I have to get them on. Yeah, they friction fit fine. And the two solder pads meet, and that's the way we will affix them. We will put solder on those solder pads to keep the sides together. And that's why you want to put the solder pads on the inside, because it wouldn't do you any good on the outside. Well, I guess I guess it has solder pads on both sides. I did not know that. But we just solder a little bit in there, as you can see, and it'll keep the sides on. And they say make sure it's perpendicular, and it's perpendicular enough. And that's those sides. By the way, this is pretty well designed. This mechanical part is going together pretty well. I like it. And now we do one more piece, which will be the prow and the stern. Now the other final hull piece. And there, the hull is all together. Now we will put the mast on. And we got to get this right, because the mast is also sending power. These pads are not just for support. You see there are two of them. That's sending power up these leads to these other ones that have the LEDs on them. So you want to make sure you get that right, and you also don't want to put it backwards, because if you put it backwards, then power is not going to be going the right way. And that would be unfortunate. Again, I still don't have the IC, the microcontroller, installed yet. I think that's good. Now I'm going to check this, just because that's the kind of guy I am. I'm going to make sure I've got continuity from down here at the base to still. Oh, who switched that to volts AC? Oh, I meant to turn it off and I switched it to volts AC. Huh. Okay, so we'll tap there and Yep. And we've got continuity all up the mast on that one. And maybe it's the other side. Maybe it's coming off of that one. Then why did they... I thought they had put 2 pads there because those were the positive and the negative sides, but I could be wrong. It could be this H solid side is carrying current also. Let's see. Yep. Okay. So that's all done. And it's very secure. Now we'll put our conning tower area in, or our, I'm going to call this fire control. This is where fire control is living. Now we're going to set our guns in place. And I'm going to rotate it around this way and see which one goes on the outside. I guess I'll put this one on the outside because this is the one that only has one. And I think we're going to have to line mark AJ. That doesn't make any sense. If I align the marks AJ, it goes backwards. That's not right. Let me double check. No, that can't be right. So, and that's actually not what the picture shows either. We want the O plus facing the AJ. Now this does not, it's a little heavy. Oh, I'm switching around, so this one, the one with only one workable gun, is facing forward. Now how am I going to hold this? I'm going to grab my little tweezers, tweeze the end a little bit, and that's going to hold that in place for me. That's good. I'm going to do the other side, but I can take the tweezers off. I'll put this one in. And the only problem on this one is we've got to put solder on the inside, and I'm still going to have to tweeze this one to get it right. Now, and that's the end of assembly, so now I can put the microcontroller on board. Now, let me turn off this overhead light. I may have to turn off, I'm going to go ahead and turn off my big overhead shop light. It's just illuminated by my iPad right now, and I can turn that off too. So we'll plug the USB-C cable in, turn the switch on, and there we go. Do-do-do-do-do! Okay, sideways. It's overpowering the camera. And we don't have any lights on the mast. Interesting. Let me see if I'm going to turn one light back on because this really is overpowering the cameras. I'll just turn the light away. And all the LEDs seem to be working. The Canon is working. We don't have any of the mast power coming on. I don't know why. Let me press this button. Get different light pattern. I'm not hearing anything. So the music is not working. Let's try another light pattern. Another light pattern. Another light pattern. That's back where we were at the beginning. And the question is, why are we not getting power to the mast? Why the music isn't working, I don't know. I've had a lot of trouble with, if that chip's not pre-programmed right, then you're going to have a problem. So since I don't know what's going on here, I'm going to check and see if we've got, where's the other end of my meter? Make sure we got power coming up here. Oh well. And of course I don't have sound, because when I make, this is like the second one of these in a month or two where I haven't gotten sound when I expected sound. I think the chip got zapped. Again, again, you saw it. It wasn't in any protective film or electrostatic sensitive foam like this. It wasn't protected at all. So might have lost its zap, might have lost its programming, but that's okay. Even with just those lights, it's kind of neat. Again, I wish that mast would work, and I don't understand where it can be losing a volt or two. I'm going to probe it one more time here just to make sure. So there you go. I'm going to bring the light a little bit closer again. So it's a good kit. I like it. I like the mechanical design. I'm going to just turn it on and off. You never know. And no, that didn't do anything. I like the mechanical design. It goes together better than most kits I've put together of the 300 or so I've done on my channel, and 150 of the general purpose kits. It goes together mechanically much better than many of them. It's a little challenging to do the surface mount parts. I did a little more poking around, and even though where's my pointy thing? There it is. Even though I had done the top connections on the mast, I hadn't done the bottom ones because I didn't think they were necessary, because I was getting voltage through there. But I did the bottom ones, and there we go. The mast comes on. So that's fixed. I still can't figure out why the music chip isn't working. I checked the voltages going in. It's got fine voltage coming out, going into it. So I don't know what's going on. But again, at least I fixed the mast lights. So overall, this is a very good kit. I like it quite a bit. The mechanical design is good. The mix of through-hole and surface mount is good, and it's a good little concept. Unfortunately, I don't have music and I don't have mast lights. But that's okay. That happens. And, as always, I hope you enjoyed the video.